we are now going to enter into the realm of finding the area of irregular figures. Irregular figures are shapes, well, I should say figures made up of multiple shapes, none of which fit to our cookie cutter area formulas. Let's dive right into that. They're really neat problems. So let's look at part A here. We're asked to find the area of this irregular figure. And most figures in this world are irregular, but we can break them down into simple pieces. And that's what this is all about. The whole point of these problems is not necessarily to learn how to find areas of irregular shapes, but to see how harder problems can be broken down into simpler pieces. And once you have the plan of what those simple pieces are, the problem becomes a lot easier. Sounds like the real world. When you have a big project and you have to break it down into simpler parts, once you execute those parts and you sum up those parts, you get a whole great problem solved, or a whole great project. Let's look at this. So, a couple different ways we can look at this problem. The first way is we can split this into smaller, easier parts. So I'm going to put dotted lines here. I make a dotted line a little bit more solid there and there. And what that does is we see that we have what looks to be a square, a rectangle, and another rectangle here. And if we can find the areas of this guy here, I'll call that A1, A2, and A3. If we can find the area of A1, A2, and A3 and add them all up, we'll have the whole area. So that's our plan. Area of 1 plus the area of region 2 plus the area of region 3 equals the area of the whole. That's going to be our answer. So I'll say the area of the whole, or W. So each of these numbers, by the way, are called subscripts. A script is a writing or something written. Sub means below. They just indicate different areas. So let's find A sub 1 first. So I'll do that work here. So A sub 1, actually, I'll just kind of do it out within the A sub 1 block. We need A, well, first recognition of what shape it is. It's a rectangle. So we've got what looks to be a length and a width here. Well, that's 10 inches. And then we have this amount. Well, it's the whole thing is 12. That whole distance here is 12. So how long is that? Well, we know that this is 4 inches right here. The whole thing is 12, which means we're taking 4 off of 12, which means this amount right here is 8 inches. Ah, nice. So the area of A1 is 10 inches by 8 inches. So I'm just going to write that right here, 10 times 8. And that's A sub 1. Now we go to the next part of our project, A sub 2. Well, we have this is 3 inches. We know this is 4 inches. So that's also 4 inches. And we have another rectangle, 4 inches times 3 inches. And that's A sub 2. Isn't that cool? I think it's so awesome. All right, plus the area of this third region. Well, that already has all our dimensions. We've got 4 by 4, or 4 times 4. And that'll give us the area of the whole amount. There you have it all. We went piece by piece, broke it down, and once we broke this problem down, we were able to then solve. So now we'll just simplify to find our total area. 10 times 8 is 80, 4 times 3 is 12, and 4 times 4 is 16. Then that, when we simplify it, is going to be equal to 80 plus 12 is 92, plus 16 is 108. Our units are going to be inches squared because we're finding area. And that's the area of the whole thing. That is so rad. Okay, now there is another way that we can find this area. So I'm going to erase a little bit of the work here. You can always rewind the video to see what it looked like before. So we've got A1, A2, break all that stuff out. So I'm going to leave the measurements that we found before out of there. Now, the other way we could look at this, and this is pretty creative, is we could complete this entire rectangle. So you look at the whole thing and think of it as a 10 by 12 rectangle. So really I'm saying the area of the whole, which we call W, minus, and I'll call that A sub 4, right? Or area sub 4. The area of that little part right there. This. We want to remove that, right? So if we remove that little piece, we'll have the whole area. Well, the area of the whole is 10 by 12, or 12 by 10, length times width, minus the area of what we'll call area sub 4, which we know is 4 by 4. And when we do that out, that's going to be 120 minus 16, which is, we got a slightly different answer right there, which means I must have made a mistake in some of my math, or something wasn't consistent. Oh, I did make a mistake. I love doing out the problems live because I can show you what that mistake is. It's not a 4 by 4 area. we assume something here. This amount here is 4 inches. This height is not 4. We have the total is 10 inches. This is 3. That's 4, which leaves us with 3 more inches left right here. Nice. So another way we can catch our mistakes, and you'll never know if I did it on purpose or not. So 120 minus 4 times 3 is 12. 120 minus 12 is 108 inches. So making the assumption that this is 4 can be an error, as I showed right there. We do 3 plus 4 is 7, subtracted from the whole of 10 gives us the remaining 3. The whole idea here is that you're getting your plan down and you're executing that plan, being careful as you execute it. Personally, my brain works better this way, but I think subtracting out a little piece from the whole is a neat way of doing things. All right, stick around if you want another example, and I hope that you do, because I'm going to go right into it. Another irregular figure. So this gives us a rectangle and a triangle. I think the easiest way of doing this one, there won't be any subtraction here, is just very simply the area of the rectangle. So I'll call that area sub R and area sub T, or triangle. So maybe I'll do little shapes. How about that? Is that good? So you've got the area of the rectangle plus the area of the triangle, and that'll give us the area of the hole that we want. I'll call that just the area. So let's find the area of the rectangle first. Well, that's going to be length by width, and that gives me the whole area of that. So that's going to be 30 times 12. On top of that, now we need the area of the triangle, but I don't have many dimensions of this triangle. Let's see if we can find them. Well, I need 1/2 the base times the height. Well, I have this whole thing is 30 right here, and that amount is 13. If I subtract 13 from 30, I will get the remaining amount. We'll do a little bit of side math. 30 minus 13 is equal to 17. So this part right here is 17. I still need the height. Well, we're in luck. This whole amount is 20. That amount right there is 12. If I subtract 12 from 20, I will get the remaining amount. So 20 minus 12 is equal to 8. Some dots right there, we get 8. And so now that's my height. So now I have a basic triangle right there. So I'm just focused on this, thinking I need to do 1/2 the base times the height. Isn't that awesome? So I'll do 1/2 the base, which is 17, times the height, which is 8. Now, when I simplify this out, I'm going to be doing 8 times 1/2 first because it's an even number. I can do that with the commutative property. 30 times 12 is 360. Plus, as I said, half of 8 is 4 times the 17 that's still remaining. 4 times 17 is 68. So 360 plus 68, and that's going to equal to 428. Its area, square centimeters. Isn't that a beautiful thing? Oh man, area plus area gives you your final answer. These problems are all about finding the missing information using a little bit of addition and or subtraction, and then setting yourself up with a really nice blueprint and following that blueprint. Be careful to check that your dimensions make sense, as I did in that first problem, to catch any errors. See you in the next video. It'll be just as cool as this one, I'm quite sure.